Okay, moving on with the rest of the chapter. As with the natural numbers on ordinals, we also define the +1 operation to be the ordinal union the set of itself. Notice that if we take the class of all ordinals, this cannot be a set, it must be a proper class. Imagine that it were a set. Then ord +1 would also be a set, and we already know that that this must be greater in the ordering relation, and yet it would be pretty direct and straightforward to show that ord +1 would then be an ordinal, and one way or another, either through being less than or being equal to, we could get that there is a contradiction with the ordering relation. So ord +1 cannot exist, right? That's not a set, and nor is ord. Now we'll prove a theorem, which is that every well-ordered set is isomorphic to some ordinal. And the way that we are going to set up this proof is to basically make a function from the set of initial segments of W to, or in fact, from W to the class of ordinals. And in particular, we will do it through initial segments, right? Defined in some way that has to do with initial segments. But the point is that every element in W will get mapped to an ordinal, and then the image of this function will itself be an ordinal. We will do this in a one-to-one way, and that will get us an isomorphism to that ordinal. So, to actually tell you the details of the proof, rather than that very rough sketch, we select any element out of our well-ordered set W, and claim that there must be some ordinal which is isomorphic to the initial segment given by X. Suppose for contradiction that the initial segment is not isomorphic to any ordinal, then the set of all things for which the initial segments are not isomorphic to any ordinal forms a set, and must have a least element being a non-empty subset of W. And so we call that least element Y. Now, we could have that this initial segment is the empty set, but then if we did so, we could easily set up an isomorphism between that and the empty set, and therefore it could not possibly be the least element. Okay. So we have that this initial segment is not the empty set. But this then tells us that that there is something included in this initial segment, and therefore less than Y. And from this, we can, again, set up an isomorphism. This tells me, being less than Y, and Y being the least element, there is an isomorphism from the initial segment given by Z to some ordinal, call it beta. And from the existence of such an isomorphism, all you have to do is extend it to Y, and that it is very easy to show that the extension to Y will map to beta +1, which we, here I call alpha, and you get a contradiction that way. So I have just established that for every element of W, there exists an ordinal isomorphic to the initial segment given by it. I will continue the proof in the next video. This was mostly set up to really get into the proof.